This is the kind of chemical reaction that's made from two half processes, reduction and oxidation, which together will give you the complete chemical reaction of redox, okay, reduction and oxidation. Now, redox can be understood in a number of different ways. All of them are interesting, and mainly you have a lot of things to watch out for when you're doing your observations, because there'll be plenty of appearances of color changes, production of gases, production of solids. So all in all, redox is the stuff that we actually generally associate with chemistry. So let's start with the first kind of definition of redox. We can understand redox from four different ways. The first three are relatively easy to talk about. The last one takes a little bit of working on. All right, so let's first talk about the first definition. Redox can be understood from the point of view of the gain or loss of oxygen. So, gain of oxygen actually refers to oxidation. Loss of oxygen, therefore, will refer to reduction. So as you can see, the two processes are actually like complementary to each other. When one gains, the other one loses. When the other one loses, this one gains. So they actually do the opposites to each other, but they belong to a whole complete type of chemical reaction. So coming back to oxidation being the gain of oxygen, all right, if I were to burn anything that contains carbon in air, the carbon aspect of that thing would actually combine with the oxygen in air and form carbon dioxide. So in this sense, you can see that carbon gained oxygen, right, to become carbon dioxide. Hence, carbon was oxidized. All right, and at the same time, if I'm taking a look at, let's say, the reaction of copper 2 oxide with hydrogen gas, and let's say hydrogen gas snatched the oxygen from copper 2 oxide, resulting in the formation of copper metal and water, if that's the kind of chemical reaction we're talking about, all right, then copper 2 oxide actually lost oxygen and became copper metal. So in that, what happened was copper 2 oxide was reduced to copper via this loss of oxygen pathway. So as you can see, in a chemical reaction, you could have the appearance of gain of oxygen. You could also have the appearance of loss of oxygen. Gain of oxygen would mean that oxidation has taken place. Loss of oxygen will mean that reduction has taken place. So that is the first and the simplest way of understanding redox. Now, let's talk about the second one. The second one understands redox via the gain and loss of hydrogen. So in this respect, you need to understand that hydrogen is considered to be like element to oxygen. So whatever happens to oxygen, the opposite will be happening to hydrogen. Okay? So in other words, the loss of hydrogen would be regarded as oxidation. And anything that gains hydrogen will therefore be regarded as having been reduced. So in the same way, you have to actually take a look at the chemical reaction, right? Now, the third definition is something that is unusual, okay? We understand redox from the point of view of gain or loss of electrons. Now, keeping in mind the fact that electrons are negatively charged, if I talk about the gain of electrons, you kind of like, you can think about it this way, you kind of like became, by gaining electrons, you became more minus. You got reduced, right? So the gain of electrons actually is an act of reduction. So therefore, the opposite must be true. Anything that loses electrons, therefore, is said to have been oxidized. So some of the more common examples of redox this particular way would be like the formation of ions. Okay, metal atoms which lose electrons to become cations are all said to have been oxidized. Why? Because they lost electrons. And all those non-metal atoms that gain electrons to become anions, they have all been reduced. Why? Because they gained electrons. So for the first three definitions of and ways of understanding redox, which I just went through, gain loss of oxygen, gain loss of hydrogen, gain loss of electrons, okay? These three are the first three most basic ways of understanding redox. The fourth way, I will talk about it in the next video, and that one's far more complex, but that one's also far more interesting. So if you like what you hear, please click a like, and I hope to see you at my channel. Thank you for your support.
I got my head out the sunroof, I'm blasting off